start to record our lesson, and let's get started for today. Okay, I think Geo is here, so I don't know why I didn't mark him. And then we're just missing Bry Guy today. Very cool. Not cool that he's missing, but very cool that we're only missing one friend. So let's take a look-see at this guy here. So we're getting ready for our assessment that we're going to be having next week. And when I say assessment, that means a test, but I like to use the word assessment because I feel like it's a better representation. So we're looking at some of the questions that we might see on this assessment coming up. So number one, the test type of question that we're going to look at first is which one includes this point. So it says the solution to a system of equations is 6, -3. Choose two equations that might make up this system. So what we need to do is we need to look for two equations that when I plug this coordinate pair in for x and y, will make it a true statement. So if I look at this first one, A, and I'm going to plug it in and I'm going to test it. I'm going to say y is equal to -3x plus 6. And I know that my y is, what's my y value in this ordered pair? We're testing this ordered pair. What's my y value? X comma y -3 is equal to -3 times x. What's x going to be? Is anyone alive out there? Can anyone hear me? Very good, Matthias. Yes, it's going to be a 6. Very good. 3 times 6 plus 6. So I have -3 is equal to, what's -3 times 6? -3 times 6. Very good, Rashem. -3 times 6, that's like saying 3 times 6, which is 18. And it's going to be negative. And we're going to add 6 to that. So we're going to think it's saying that -3 is equal to, what's -18? Nice job, Tiffany and Destiny on that. Plus 6. -18 plus 6. You're going too high, Destiny. You're going the other way. Very good, Tiffany. So -18 plus 6. Very good, Melissa. Very good, Camilla. Not a problem. Very good job there, Destiny. I'm really proud of you on that. Nice job, Matthias. It's going to be -12. Very good, Olivia. So -3 is equal to -12. Is that correct? Is that a true statement? -3 is equal to -12. Is that true? So -3 is equal to -12. That's a true statement. It's not. Very good. So this guy is not going to be part of that system because when we plug that when we plug those numbers in, they should be true. It should be -3 is equal to -3 or whatever it might be. Okay. Now we're going to test another one of these coordinate points. Oh no, we didn't. We lost somebody. I don't know who it was though. So we're going to use this now, the second equation. I'm in the wrong box. Give me 1 second. Let me just let this person back in. Jocelyn fell out. Now she's back. So now we're going to test out B, where it says y is equal to 2x minus 9. Okay. And we know that our y is equal to -3 is equal to 2 times what's our x? Very good. Very good, Matthias. It's going to be 9. I mean, no, not 9. What's our x? It's our 6. Very good. That's okay. That's not a problem. Thanks, Jocelyn. I figured like your internet fell out for a second. That's not a big deal. So it would be 2 times 6 and then minus 9. Okay. So we'd be left with -3 is equal to, what's 2 times 6, guys? Very good. 2 times 6 is, very good, Melissa, Tiffany, Jocelyn, Camilla, Rashem, Matthias. Very good, Melissa as well. 12 minus 9. What's 12 minus 9 going to get me? 12 minus 9. Very good, Melissa. Very good, Jocelyn. Very good, Shelby and Destiny. It's going to get me a 3. Well, is it a positive 3 or negative 3? Very good. It's going to be a positive 3. Very good. So we have this statement here. We come down to the end and it says -3 is equal to 3. Is that true? Nice job. Thank you, Melissa. -3 is equal to +3. It's not. Very good. Nice job, Destiny, Melissa, and Matthias. Very good. I like it. So this guy is not going to be in our system either because it's not true. It's not true. Now we're going to test one of the other ones. So we're going to use the same ordered pair, and we're going to test this third one here. That is y is equal to -5. And you can be typing this, by the way, x plus 27. Ooh, goodness, we have some big numbers here. We know that our y is -3 is equal to -5 times what? What's our x? Very good. It's 6. Very good. I like those exclamation points. And then we're going to add 27 to it. So we're going to say -3 is equal to 5 times 6 is 30. So what kind of 30 is it going to be? It's going to be a negative. Very good, because we have a -5 times a +6. So it's going to be -30 plus 27. Okay. So what's -30 plus 27? Oh, wait. Yeah, nice job, Destiny. That's okay. Not a problem, Tiffany. You're doing great. So -30 plus 27 gets me a -3 is equal to -3. Oh, goodness. Is that a true statement? Is that true? Yes, it is. Woohoo! So that means C is one of our equations here. So I'm going to grab one of these circles. I can't grab one of these circles for some reason. I'm going to grab one of those orange circles and I'm going to circle the letter C because that is a true statement. Very good, Matthias and Destiny and Melissa there. Love it. That's what I'm loving. That's what I'm living to see. Now let's test out D here, where we say y is equal to 2x minus 15. Okay. So y is equal to the -3. -3 is equal to 2 times, what are we thinking? Very good, Melissa. She's on 6. And then we're going to subtract 15. Take a moment to complete that for me. Let's see what we get. -3 is equal to -2 times 6 gets me. Ooh, Shelby knows. Shelby went all the way. Nice job, Shelby. 2 times 6 is, very good, Matthias. It's 12 minus 15. Ooh, so then we're left with this -3 is equal to 12 minus 15. What kind of number is it going to be, guys? 12 minus 15. Let's do it. 12 minus 15 It's going to get me a 3, but it's going to be a -3. Use your calculator. Very good, Tiffany, Melissa, Rashem, Matthias. Very good catch there, guys. Very good. So it's going to be -3 is equal to -3. So what am I going to do with letter D? Is it a true statement? Not a big deal. You're doing great.
Yes.
It's a true statement. Yes, it is. Nice job. So we're going to circle the letter D, and then we don't even need to test E because we already have our 2. Very good. Very nice job, guys. I'm going to leave this up for another 20 seconds so that you can get this written down in these boxes. If you have to make the font a little bit smaller for it to fit, please feel free to do that and get those boxes typed in. Okay, very nice. Or if you wanted to do it on paper, you can take a picture and insert it that way. What's wrong with you? You good, Matthias? Oh, okay. Because you did like the face. I wasn't sure what that meant. Okay, so once you get this written down, we're going to go to slide number 3. Slide number 3, if you're in your textbook, it lives on lesson 6, practice problems. So we are in lesson 6, practice problems on the next slide. I'm going to give another 10 seconds for you to get this written down. Oh no! Tiffany! I'm sending you good vibes. I'm sending you good vibes. What does that mean, Matthias? Why are you doing the tired face? Tiffany, did you squish it? Oh man, I'm so sorry about that, Matthias. Hopefully you squished it, Tiff. Perfect, very good. Tiffany. Okay, so now, this is my favorite question. So the thing is in the book, the question isn't worded like it is here. It's just in the book, it's just this graph here that we're using. So next to the graph in the book, you can answer these 3 questions and you can like number them 1, 2, 3, 4, and 5. And then you can do like T, F, whatever. Okay, do you see that? That how you might want to do it that way? So it says decide if each statement is true or false using the graph. Okay, so it says the height increases quicker between 0 and 2 minutes than it did between 3 and 5 minutes. So it's saying it's quicker between 0 and 2, that's this segment right here, than it did at 3 to 5 minutes. Is that a true statement? Yes or no? Or is that true or false? What do we think? Does it increase quicker on this first segment here than it does in that second segment? Is that a true or a false statement? So Melissa's saying, Melissa gave me an answer. Nice job, Melissa. I'm going to give you another 25 seconds to give me an answer. Is it increasing quicker between 0 and 2 than it does on that green segment of 3 and 4? Matthias, thank you, Matthias, on that one, my friend. The height increases, very good, Edgar. The height increases quicker between 0 and 2 minutes than it does between 3 and 5 minutes. And I color-coded these segments here. Very good, Edgar. So I have a couple people that are saying that this is actually false. So you can move one of these X's into the box that you think. People are thinking that it's going to be false. Can I have someone tell me why they think that that's false? Edgar, what are you thinking there, my friend?
I think it's false because the line from 3 to 4 is steeper than from 0 to 2.
Very good. So the line here is steeper which means that it's rising faster. So this first statement here, number 1, is false because on the graph, this little leg of the graph is steeper, where it goes up faster. Very good, nice job. That was a good explanation, Edgar. It was really clear. Okay, let's look at the second question here. Okay, there are 2 intervals or pieces where the heights stayed the same. Is that a true statement? Are there 2 separate pieces where the height stayed the same? Is that true or false? What do you think, Joe?
I said that I think the height does stay the same.
Where does it stay the same?
At around like 25 height.
Oh, at a height of 25. Okay, so here. And then
so
is
it goes to 30 and then it just goes down to 25 and just stays at a constant.
good. So that's one interval where it stays the same. Is there another spot where the height stays the same? It might be a different height, but is there another spot?
Yes.
Where do you see it, Joe?
At 10, over to between 2 and 3.
Very good. So this segment right here, the height is staying the same. So is this statement true? There are 2 intervals or pieces where the height stays the same. Is that true or false? Let me know in the chat. What are we thinking?
Yes. True.
True. Okay. So I'm going to say very good, Matthias. Very good, Tiffany. Very good, Melissa. This guy is a true statement because like Joe said, the height stays the same here from 2 to 3 minutes, and then it stays the same from 7 to 9 minutes. So there are 2 spaces where your height stays the same. They're not the same height, but they stay the same. So number 2 is true. Very nice job there, my friends. Awesome job. Okay, let's take a look at the next one here. The next statement says, there are 2 times when the height was 27 centimeters. So we're going to look for 27 centimeters on which axis here? Oh, no, that's not what I wanted. Give me 1 second, guys. Sorry, I just accidentally clicked off. So it says there are 2 times when the height was 27 centimeters. So we're going to look for 27 centimeters on which axis here? Which axis is talking about centimeters? Very good, Melissa. In centimeters, height in centimeters. Which axis is talking about height in centimeters? Very good, Tiffany. Our y-axis is talking about height in centimeters. So are there 2? We're going to look for the number 27. And 27 falls where? Between what 2 numbers on our y-axis? Where does 27 fall? Between what numbers here? Very good. It's going to fall between the 25 and the 30. So somewhere in between here, so we can say maybe like halfway up. Does it hit my equation line twice? Very good, Tiffany. It hits my equation line twice. So is this third statement here a true statement? Yes or no? Is it true or false?
It is false.
Well, does it hit, are there 2 times, 2 different times when the height is 27? So then that must mean that it's
True.
true. Very good. So you're going to grab one of your X's, put it in your true box because it hits 27 here and here between 4 and 5 minutes. And then again at 6 minutes. Very nice job there, my friends. Very good. Okay, so now it says there is only one interval when the height is decreasing. So we're going to look for a piece, if the height is decreasing, we're going to look for a piece where our line is going in what direction?
Down.
Down. So if we number these pieces here, so like this is number 1, number 2, number 3, 4, and 5. Give me a number, when is our equation line decreasing or our height decreasing?
4.
So Joe is saying 4. It's decreasing on 4. Is there any other times when it's decreasing?
No.
Joe says no. Do we agree? Melissa says that she agrees and she says no. Matthias says he agrees. So is this statement true here? There is only one interval or piece where the height is decreasing. Is that true or false? Yes, I see some people saying yes. I see some people saying true. Very good. Very good, Joe. Very good. So this one is going to be true. So you're going to grab one of your X's off the pile, put it in your true box because it is true. Oh my goodness, we have a lot of truths here, my friends. Last one. This one is probably the easier of the ones here. At 10, and I meant to write minutes, I'm sorry. At 10 minutes, the height was 35 seconds. Is that a true statement? Yes or no? At 10 minutes, the height is 35 seconds. Is that true or false?
False.
So when I'm looking for 10 minutes, which axis am I going to look for 10 on? Very good, Melissa. On my x-axis. So I'm going to look for 10 on my, oh, but there's no 10 here. What do I do? Where's the 10 going to be? It's going to fall right after this 9, right? So it's saying at 10 minutes, my height is 35 centimeters. If I follow it over, it's not a true statement. It's what is the height at 10 minutes?
25.
25, very good. So we're going to grab an X off our pile and we're going to put an X right in that false because it's not true. At 10 minutes, the height is only 25 centimeters. Very nice job, everybody. Fantastic work. So if you're in your book and you want to write, you don't need to write the whole statements down. You can just do like number and then like true or false. Very good. Wow, nice job. I thought I was going to be able to trick you guys, but I guess I wasn't able to. Okay. Right? Like, come on, right? Mr. Mean is silly. So very nice work there, my friends. Let's take a look at the next piece of this. Okay, if we're looking in our books, the next one, so the next slides, let me erase here. Okay, so once again, the next slides, so we're using the graphs on slide number 4, and we're matching them to the descriptions on slide number 5. So these, if you're in your book, it's lesson 6 again. Practice problems. And if you're in your book, you can flip it back one page from the one that we were on, and it's it should be right there. These 4 descriptions should be right. So we were just on this guy here. If you flip it back a page, it should be right there. Okay. Very good, very good, very good. Now, okay, we're looking here and it says Tyler pours the same amount of milk from the bottle every morning. So which one of these graphs shows Tyler pouring the same amount out of the bottle every morning? A, B, or C? Which one are we thinking here? Very good, very good, very good. Nice job, Rashem. Nice job, Edgar. So what's happening on what's happening on A? It's what? It's going up. It's increasing. But if you're pouring milk out, like because you're using milk, so it's going down. So would A be the best graph for this one? Very good. Nice change there. Very good. We're pouring milk into the bowl, but we're talking about like what's left in the jug.
Oh, B.
So it's going to be B. Very good, because we're taking the same amount out every single day. Very good. Nice job. And it's decreasing, it's going down. Very good. So B would be the best one for description A, or for description 1. So B. Now let's take a look at number 2. It says a plant grows at the same amount every week. Which one of these graphs shows a plant growing? Very good, Rashem. Very good, Melissa. Which one of these shows a plant growing at a constant rate of change? Very good, Edgar. So it's increasing, so we want one that's going up, and it's increasing at a constant rate, so it should be a what kind of line? A straight line. Very good, Matthias and Edgar on that one as well. Very good. So letter A would be the best description for number 2. Last 2 here. The day started very warm, but then grew colder. So it started warm, and then the temperature went down. Which one of these graphs do you think best shows that? It started off warm, and then it started to go down. Very good, Melissa. Graph C is going to match option number 3, because it started off warm, it stayed warm, and then the temperature dropped. It went down. So for 3, you would have letter C. And 1, the carnival has an entry fee of $5, and the tickets for the rides cost $1 each. Very good, Edgar. So which one of these graphs says it starts with a $5 entrance fee, and then it costs $1 each? So we're talking about how much money we make. Which one is very good, Matthias. This guy here is going to match this description here, because it starts with 5. So it starts on our y-axis a little bit up, $5. And then every ride is adding $1. So it's going up at a constant rate of change. So for that last one, description number 4, it would be graph letter A. Okay. Let me tell you what you guys have for homework this evening. You literally have 1 slide to do for homework this evening. If you scroll, we have slide number 6, where you have a row of inputs here. You need to use this rule right here to calculate what your outputs would be. Okay? So you use each one of those inputs to calculate your output. We're going to go through this for our warm-up tomorrow, but I want everyone to get it done for homework because it's nice and simple, okay? If you guys have questions, shoot me emails. Everyone did phenomenal today. I am so proud of all of you. Great job. I will see you guys tomorrow, okay? Awesome job today.
Bye.
Bye, bye. Bye, guys. I'll miss you. Bye, Edgar. Bye, Destiny. Bye, Jalen. Bye. Bye, Jocelyn. Bye, Joe. Bye, Mateo. Bye, Miguel.
Bye.
Mila. Bye, Sam B. Bye, Joe. Bye, guys. Sam B, you there, buddy? Jalen, you there, buddy? Good morning, everybody. It's so great to see your beautiful faces. I don't understand why Diego joined the wrong Zoom. He's in the wrong Zoom. And I cannot send him an email because I don't know why.